Hi, welcome to the present session. In this video, we are going to see the DRDO Scientist B previous year questions guys, okay, regarding the electronics and communications. And recently we got the notification from the DRDO regarding the recruitment of the Scientist B. So huge number of vacancies are there, and you may check down the eligibility criteria and all these things in the official website of the DRDO. Okay, and the candidates who are preparing for this DRDO Scientist B positions. Of course, the notification is released, but not yet the online application link is not yet released. So the examination might be within the 1 or 1.5 month the time may take. So the candidates who are preparing for this examination and the candidates who wants the coaching for this examination, so you guys may comment in this video, okay, in the comment section. You just comment that I am interested for this examination. Okay, so later I will approach you guys. Fine. Okay, so let's start these 3 questions in this video. So the first question, we are going to see this one. If you look at the question, the characteristic equation of LTE system is given as SQ plus K square plus 5S plus 10 is equal to 0. When the system is marginally stable, the value of K and the sustained oscillation frequency. That means they are asking the value of K. Okay, at the same time they are asking the omega value also. Both these two they are asking. So by looking at this question, then we can take that it is the RH criteria method. Okay, I think all of you might know. It is the RH criteria. So by using this RH criteria, that is the Routh-Hurwitz criteria, we can do this solution, guys. So let's take SQ, S square, S power 1 and S power 0. And if you take the coefficients of S cube is 1 and S is 5. So let's take 1 and 5 here. And S square coefficient is K and this constant is 10. So K and 10 here. Now 5 into K minus 10 into 1, so that is minus 10 divided by this K. Okay, and in the same way you can take here that K into something. Here nothing is there, so let's take 0, and this one into minus this one into this one, nothing is there, so we can take 0 here. Okay, and in the same way you can take down here 5K minus 10 divided by K into 10 minus 0 divided by K whole divided by this one, so here you will get as a 10. Okay, so it is how we are going to get by following the Routh-Hurwitz criteria. And from this one, if the system has to be marginally stable, then any one of the row must be completely 0. So I am taking this one. If this row has to be completely 0, then 5K minus 10 divided by K has to be 0. So from this one, 5K is equal to 10 and K is equal to 2. That means we got the K as a 2. Okay. So either now the option B and C are the wrong one. Either it might be the option A or else it might be the option D. So let's check about the omega also. So whenever we are taking this, one complete row as a 0, 0 by equating this one to 0, then we can take down the auxiliary equation. So that means above this one we are having K and 10. So here the auxiliary equation becomes is equal to K S square plus 10 is equal to 0. And from this one, K S square is equal to minus 10, right? And S square can be taken as minus 10 divided by K. I got the K as 2 here, so I will get as a minus 5. Okay, and then S is equal to if you apply the square root on both the two sides, then you will get S is equal to J root 5, right? S is equal to J root 5, and S can be taken as a J omega. Now J omega is equal to J root 5 and omega can be written as a root 5. So omega is equal to root 5. That means option D can be taken as a correct answer. Fine. So it is how we are going to solve this problem with the help of the RH criteria. And now while coming to the second question, the time required for the response of a linear time variant system to reach half the final value of the first time is. See, actually whatever the system you are taking, we are having the two different types of responses are there. One is the transient response and the next one is the steady state response. Okay, these are the two responses. Transient response will occur at t is equal to 0 and it will continue up to certain amount of time, and after certain amount of time the steady state response will start. Okay, so usually if you take some speedometers, for example let's take your bike speedometer, if you increase the accelerator, then if you are going at 40 kmph speed, then the needle in the speedometer will not jump to the 40 kmph, right? It will slowly move from 0 to 40 and then will settle down. moving of the needle from 0 to 40 is called as a transient response, and settling down at the 40 is called as a steady state response. Okay, so now you can draw the system as like this, fine, and wherever the oscillations are there, it can be taken as a transient response, and after the oscillations it can be taken as a steady state response. Got it? So now in this one, the time required for the linear invariant system to reach, okay, time invariant, they are calling that it is a time invariant system, that means which is not varying with respect to the time, to reach half the final value for the first time. So if it is a time variant or the time invariant, whatever that might be, so if it has to reach half the final value, that means if it is a final value and it is a half, right, so we can take this one as a delay time. Okay, it is called as a delay time, that is the TD, fine. And the peak time is nothing but the time taken to move from here to here, from here to here can be taken as a peak time, and rise time can be taken as a 10% to the 90%, that means to rise from 10% of the final value to the 90% of the final value, this one can be taken as a rise time. Okay, decay time is nothing but a 90% to the 10%, okay, falling down is nothing but a decay time, fine. So as per these definitions, we can take that half, okay, to reach half the final value of the first time can be taken as a delay time, that we are representing with the TD. Peak time we are representing with TP, and rise time we are representing with the TR, and decay time is represented with fall time, that is the TF. Got it? And next. So coming to the next question, here you may check down, guys. Please make a note of this question, and I am suggesting you to try this question as an assignment, and in the next video I will tell you the answer for this one. So pause the video and then make a note of this question, guys. So the signal flow graph of the network is, so here the network is given and you need to find out the signal flow graph for this one, and here the options are also given. Please make a note: A, B, C. Pause the video and then make a note of this one, and then option D is given as like this. Okay, so out of all these four options, which one is the signal flow graph for the given circuit? Okay, so take this one as an assignment and solve this one, and in the next video we see the solution. If you got the answer out of the A, B, C, D, which one is the correct answer, mention in the comment section. Okay, and as I told that if anybody preparing for this DRDO examinations, then you please mention your that you are preparing in the comment section. Okay, so then I will approach you guys. Fine. So thank you very much and all the best, guys.